Hi students, this is Sumalata. In this session we are going to discuss about tetravalency, bond formation capacity and hybridization of carbon. See, carbon is the most important element in organic chemistry. This carbon belongs to 4th A group. It is a non-metal. Its atomic number is 6, electronic configuration is 1s2, 2s2, 2p2. Valency electrons in carbon are 4 electrons. So that its valency is 4. So it is a tetravalent element or atom. Its electronic configuration, electronegativity is the 2.5. See, these are the general introduction about carbon. In general, all elements wants to acquire noble gas configuration. In the same way, carbon also wants to get noble gas configuration in its outermost shell. To that one, see here, carbon lies between helium and neon. These two are the noble gases. If carbon wants to get helium's configuration, it need to lose 4 electrons, 2 out, and then it will become C4 plus ion. This C4 plus ion is equal to the helium's configuration. Helium is the atomic number 2, that means 2 electrons present in helium. In the same way, C4 plus ion also has 2 electrons. But this case is not possible. Why? Because to lose 4 electrons stored, it needs more energy. So that it's a remote possible condition. Coming to another case, if carbon wants to acquire neon's configuration, what happens here? It needs to get 4 more electrons, then it will become C4 minus ion. This C4 minus ion is equal to the neon's configuration. That means neon has 10 electrons. This C4 minus also has 10 electrons. But the thing is here, carbon has only 6 electrons, 6 protons in its nucleus. But those 6 protons are can't able to bear 4 more electrons from outside. And the another thing is, carbon is the less electronegative atom. If it is a less electronegative, it can't able to attract more electrons from outside. So that these two conditions are not possible. At this time, what happens here? Carbon can share electrons with other atoms and form covalent bonds. See, during this procedure to form covalent bonds, during this procedure, carbon can get octet configuration in its outermost shell. Okay, see, this covalent bond formation is different types, because so many bonds can able to formed by this tetravalent carbon atom. See here, if you can, the first one is the carbon can able to form 4 single bonds and 4 single covalent bonds and with the same atoms are other atoms. See, if for example, if you can take methane, in methane carbon can form 4 single covalent bonds with 4 hydrogens. These 4 hydrogens are belongs to the same element. Coming to another one, carbon can able to form 4 covalent bonds with different atoms from different elements. See, chlorine, bromine, iodine and hydrogen, these 4 are coming from 4 different elements. Coming to another one, it can form bonds with itself also. If carbon can form bonds with itself, that capacity is the catenation capacity. Coming to another one, carbon can form one double bond and one single bond, I mean not one, two single covalent bonds with the other atoms. See here, example, C double bond C H H. This is one example. You can take another one, C double bond O HC H3. See here, this one also possible. Coming to another one, carbon can able to form one triple bond and one single bond with other atoms. See here, C triple bond C H H. This is one condition. The C triple bond N H. This is one more example. Coming to another one, carbon can form two double bonds with other atom. See here, C double bond C. This one also possible. You can take another CO2 molecule. If you can take C double bond O double bond O. These are the different types of bonds formed by the carbon because of its tetravalency. During this formation, carbon can fulfill its octet configuration. Coming to next one, here this tetravalent nature of carbon and this bond formation capacity can explain by its electronic configuration. Electronic configuration of carbon and hybridization of s and p orbitals present in it. Okay, see here this point. The tetravalent nature of carbon and different types of bond formation capacity can be explained by the outer electronic configuration of carbon and hybridization of s and p orbitals present in that carbon. Okay, in general, the carbon atom present in organic compounds will undergoes sp3, sp2 and sp hybridizations. Okay, mainly these three hybridizations are we are going to observe in most of the carbon containing organic compounds. Next, coming to how carbon can form these many types of bonds by using electronic configuration and this hybridization. Let's see now. Okay, see here, if you can take first condition, how carbon can take 4 single covalent bonds by using electronic configuration and hybridization. To knowing this one, we can take methane as an example. In first condition, you can take methane CH4. In CH4, if you want to know what is the hybridization present in carbon atom, to that one you can use a formula. See here, carbon attaches with 4 hydrogen atoms. The hybridization present in carbon is equal to the number of atoms attached to that central carbon atom. Here 4 atoms are attached to the central carbon atom and lone pairs present on that central atom. Here there is no lone pair, so that the hybridization value for carbon is the 4 we get. 4 means that is sp3 hybridization. To observe this sp3 hybridization, you can take electronic configuration of carbon. The ground state electronic configuration is the 1s2, 2s2, 2p x1, 2p y1, 2p z0. This is the ground state. You can take excited state. If you supply some energy, then this 2s orbital will goes to the 2p z0. So 2s1, 2p x1, 2p y1, 2p z1 is the excited state electronic configuration. See, now 4 single unpaired electrons are present in carbon atom. Those are available to formation of bond. But here all those electrons are not present in the equal energy level. Those are present in the different orbitals. Those different orbitals are possess different energy. So to equalize their energy, these orbitals are going to be redistribute with each other. So see here, this is the 2s orbital, this is the 2p orbital. Each one has one electron. To equalize this one, 1s and 3p will going to be involved in redistribution. Then they will form 4 sp3 hybrid orbitals. See, now 4 sp3 hybrid orbitals with single electrons are ready to involve in bond formation. Coming to hydrogen, hydrogen electron atomic number is the 1, its electronic configuration is 1s1. That means only one electron present in its 1s orbital. So here how these 4 sp3 hybrid orbitals lies around the carbon. See here, if it is a carbon, this is one hybrid or sp3 hybrid orbital, this is another sp3 hybrid orbital, this one and this one. 4 sp3 hybrid orbitals are lies around the carbon like this. Okay, see, each one possesses single electron. sp3, this is sp3, sp3, this is a sp3. The bond angle present between these orbitals is 109 degrees 28 minutes. See here, after that the 4 hydrogens are going to be involved in bond formation with these 4 sp3 hybrid orbitals. See, this is the one hydrogen atom involved in bond formation with one sp3 and another hydrogen. This is one hydrogen and this is one hydrogen. See, this is sp3s sigma, sp3s sigma, sp3s sigma. This is also, all are sigma bonds, 4 single covalent bonds. See, it is a carbon. Okay, this is one hydrogen, this is another hydrogen, this is one hydrogen, this is one hydrogen. Bond angle is 109 degrees 28 minutes. It is the tetrahedral geometry. Okay, it has tetrahedral geometry. See, in this structure, the normal lines indicates the in plane equal to the plane, and this dotted line indicates the back of the plane. Okay, this thick line indicates the front of the plane. That means out of 4 hydrogens, 2 are present in plane, one present in back of the plane and 1 present in front of the plane. This is about sp3 hybridization. By using electronic configuration and sp3 hybridization, how carbon can form 4 single covalent bonds. During this formation of single covalent bonds, carbon can fulfill its octet configuration in its outermost shell. Coming to next bond formation. See here, the next bond formation is the how carbon can form one double bond and two single bonds. To that one you can take C2H4 is an example for that one. In C2H4 molecule, the structure is like this. See, here one double bond and two single covalent bonds with other atoms. See, here to know carbon's hybridization in this molecule, how many atoms present around this carbon atom? 1, 2, 3. 3 atoms attaches with this carbon atom. There is no any lone pairs for this one also. So, it is 3. 3 means sp2 hybridization. Coming to electronic configuration, in the same way as like previous condition, ground state and excited state. After that, one s and two p orbitals going to be redistributed with each other. Then they will form 3 hybridized sp2 orbitals and one unhybridized orbital is there. These 3 will possess equal energy. Then coming to here, how these hybridized orbitals will going to be involved in double bond and two single covalent bonds. See, these are the hybridized orbitals from one carbon atom. This is the unhybridized orbital from this carbon atom. See, it has one electron. This one also, this one also, this one also. See, and coming to this one is the hybrid orbital from another carbon. These two are also hybrid orbital from that same carbon. See, and this is the unhybridized p orbital, possess one electron. Okay, see here, these here 4 hydrogens are there. Out of 4, 2 hydrogens going to be involved in bond formation with one carbon, and the remaining 2 will going to be involved with the other carbon atom. See, this is one hydrogen, this is another hydrogen. This is a sp2s sigma bond. This is also sp2s sigma bond. Here the remaining hydrogens also same, sp2s. This is a sp2s sigma bonds. Okay, 4 is sp2s sigma bonds. See, this is the sp2 sigma bond. Okay, coming to this unhybridized p orbital, this one will going to be involved in bond formation with another unhybridized p orbital present in the another carbon. This is the pi bond. See, with respect to this carbon, it can form 2 single covalent bonds and one double bond. Okay, with respect to this carbon, same as like this carbon. So here, by observing this sp2 hybridization, how the electronic configuration of carbon will involve in double bond formation and 2 single covalent bonds by this carbon. Okay, coming to here, bond angle in this one is 120 degrees. The 3 sp2 hybrid orbitals are oriented in 120 degrees angle. The shape of this molecule is the planar shape. This is about one double bond and 2 single covalent bonds by using electronic configuration and sp2 hybridization. Coming to another one, Another one is the triple bond and one single bond formation by carbon atom. See here, for that one you can take C triple bond CH. In this one, what is the carbon's hybridization? Carbon attaches with two atoms only, so 2, plus there is no any lone pairs, so it is 0. That means 2 is equal to sp hybridization. See here, only one s orbital and one p orbital will redistributed with each other. They will form two sp hybridized orbitals and two unhybridized p orbitals are there. As usual, hydrogen has one electron in its 1s orbital. Coming to how bond formation takes place here. This is the one hybridized orbital from one carbon. This is another hybridized orbital from that carbon. Each one has single electron. Okay. See here, this is the unhybridized p orbital. Okay. And this one also another unhybridized p orbital present in that carbon. Coming to another carbon, these two are the hybridized sp orbitals. See, sp. This is also sp. This is the unhybridized p. This is the another unhybridized p. Each one possesses single electron. See here, two hydrogens are there. Those two hydrogens are going to be involved in bond formation with each carbon. See, sp-s sigma bond, sp-s sigma bond. Here, this is the sp-sp sigma bond. sp-s sigma bond. This is hydrogen. See, coming to unhybridized p orbitals. Here, this unhybridized p orbital going to be involved in bond formation with another unhybridized p orbital in another carbon, and this is also same. See, this is one pi bond and this is another pi bond. Here the bond angle is the 180 degrees. Bond angle is 180 degrees and geometry of this one is linear only. Linear. This is about how carbon can form one triple bond and one single bond with other atom. In the same way, you can take one triple bond and one single bond formation in HCN molecule. If you take HCN molecule, here carbon's hybridization is the sp only. See, carbon attaches with two atoms, this side one, this side one. So it is carbon has sp hybridization in HCN. If you take nitrogen, nitrogen attaches with only one atom. So 1 plus nitrogen has one lone pair, so that 1 is equal to 2. That means nitrogen involves in sp hybridization in HCN molecule. Hydrogen is not involved in any hybridization. See, you can take electronic configuration for nitrogen. Here nitrogen is for nitrogen we can take only ground state electronic configuration for hybridization. No need to take excited state electronic configuration. See, 1s2 2s2 2p x1 2p y1 2p z1. Okay, this is the nitrogen's ground state electronic configuration. See here, see, this is the 2s of nitrogen, this is the 2p of nitrogen. See, these are involved in redistribution with each other. They will form, I mean, here all are not involved. Nitrogen also involved in sp hybridization. So, one s and one p. Remaining are unhybridized orbitals. See, these are the sp, these are the unhybridized p orbitals. See how nitrogen and carbon involve in bond formation. These are the hybridized orbitals from carbon. Each one has single electrons. This is the unhybridized orbital from carbon. This is another unhybridized orbital from carbon. See, okay, coming to nitrogen. Nitrogen, this is the hybridized orbital from nitrogen. This is another hybridized orbital from nitrogen. That one possesses 2 electrons. That means this is the lone pair, not involved in any bond formation. Okay, coming to, this is the unhybridized from nitrogen. This is unhybridized, another p from nitrogen. See here, one hydrogen is present in HCN molecule. So that hydrogen will going to be involved in bond formation with this carbon, okay, not with nitrogen. So this is the sp-s sigma bond. See, this is the sp sigma bond. These are the lone pairs. Coming to unhybridized orbital. These unhybridized orbitals will lateral overlap with each other. They will form pi bonds. See, this is one pi, this is another pi bond. This is about triple bond formation in HCN molecule. Okay, coming to next one, how carbon can form 2 double bonds. See, for formation of 2 double bonds by carbon, you can take an example, CO2 formation. In CO2, carbon will undergo sp hybridization. See, carbon can attaches with 2 other atoms only, so that there is no lone pair, so it is sp. Coming to oxygen, oxygen attaches with only 1 atom of carbon, plus oxygen has 2 lone pairs. So oxygen hybridized value is the 3, that means it is equal to sp2 hybridization. Now you can take oxygen's electronic configuration. See, here also you can take ground state electronic configuration. No need to take excited state electronic configuration for oxygen. For carbon, you can take excited state electronic configuration. See, oxygen has 1s2, 2s2, 2p4. This is the 2s2. This is the 2p4. See here, oxygen undergoes sp2 hybridization, so that s and 2p, they will redistribute with each other. They can form 3 sp2 hybrid orbitals. Those are possess equal energy. This is the unhybridized p orbital present in oxygen. Now coming to how these hybridized orbitals and unhybridized orbitals will involve in bond formation in CO2 molecule. See, this is the hybridized orbital from carbon. Okay, each one possesses single electron. This is the hybridized orbital from oxygen. See, the last one has only one electron, remaining are having paired electrons. We can call these are lone pairs. The remaining unhybridized oxygen see here, these are the hybridized orbitals from this oxygen and this is the unhybridized orbital from this oxygen. These are the hybridized and this is the unhybridized. These two are the unhybridized from this carbon. This is carbon, this is oxygen and this is the oxygen. See here, this is the sp2 sp sigma bond. Okay, and this is also sp2 sigma bond. Okay, coming to unhybridized p orbitals in oxygen and carbon. The one unhybridized p orbital in oxygen will going to be involved in bond formation with another unhybridized p orbital present in the carbon. It can form one pi bond. Okay, see, this is the one pi bond formation. Next, one unhybridized p from carbon to another unhybridized p in this another oxygen. This is the another pi bond. This is the two double bonds formed by the carbon atom with other atoms. This is about carbon tetravalency bond formation capacity and hybridization of carbon. See, because of its tetravalency, carbon can able to form different types of bonds to fulfill its octet configuration. So that we can say carbon has versatile nature only because of its tetravalency. I hope you understood about this video. If you have any doubts, please let me know in comment section. Thanks for watching. We will meet in the next video.